I'm the student 47. Hello, everyone. I'm the student 47. Today, I'm doing the block 2 for you. Let's get started. First of all, I want to do the emerging technologies. I have 3 three examples for you guys. One is Google Class, one is Cortex A17, and one is Google Driverless Car. First of all, Google class, when we imagine the class, we are imagining always traditionally like this, a classes. But today I want to do a cool class, a smart class. Smart class is not, I mean, it's different with the traditional, but it's still the glasses. It does not have the glass inside the Google glass. So but it does have a screen, a radio camera, and battery, and a smart, anything just like the smartphone. But it does not have the phone function. Actually, we can see here is the battery in the back of the glasses. There is a CPU inside the chips, and the GPS, and memory probably also. There is a speakers, phone. This is the first generation of the Google class. The second generation always have a micro USB port, probably behind the speakers. Also, there is a microphone. Yeah, and there is a camera. We can use camera to take a photo or record a video, and the prism is actually a screen. Like in the bottom, we can see that we see the screen in the prism. So the projector project the screens, the colors inside the prism, and we can see actually. So what we does to Google Class is we can take a camera, the photo, or we can record a video and just upload to our YouTube or something like that, or Google Plus. Also, we can ask the Google Class to show our map, or we can ask them where have a McDonald's, or we have a Cheesecake Factory, just like that. This is kind of a powerful smart device. We can say it's a post-PC component. It's a post-PC. It is still in the testing. I think it's a beta test, so people could apply for beta test and buy it in a pretty expensive price. I remember it's the second generation is $1,600, and the next one is Cortex A17. From here, I have seen a document or a journal from the emerge from the extreme.com. They says the Cortex 17 is the one replaced the Cortex A9. But actually, I believe it's not. Look at the form below. Cortex A17 has the same function with Cortex A12, but the Cortex A17 is the newer generation, and it has a better performance than the A12. But A9 is kind of different. It has a different architectures. It has the different functions. It's also used the different technologies. And then A17 and A12 are the middle range, and the A9 and A15 is targeting the high-end performance. And also why the article says the Cortex A17 is replacement of Cortex A9 is because the A17, the performance of A17 is almost achieved to the high-end. The high-end, the one is A15. So we don't need A9 anymore. It's expensive. It costs a lot of more electricities. And A17 also use the 28 nanometers, but it costs less electricity than A9. Yeah. And this is how the core combined with there is the ARM V7A CPU, and there's 4 core inside the chip, and there's many like the like many chips to help the CPU running, and there's more functions than before with the newer technology. But still, it used the 32 gigabase for the basic architecture, and it used 4 combining each other. And then it's 28. Again, I say it's 28 nanometers. It is cost more electricity than the 90 than the 20 nanometers chips. But of course, it's even if this use 28 nanobase and nanometers, but still is cost less electricity than the Intel 14 nanometers. The last one I want to present is the Google driverless car. This is a car that I'm very interested about. It doesn't need the human to drive. It drives itself. It drives machinely, automatically, and it is safe than before. Also, this one is not like in the market yet. It's also a testing machine. How it works? It has a video camera to observe the front. There is a leader. Actually, is the combining of the radar and the laser sign and radar. There has 54 sensors, including laser sign, the heat sign, and night version, something like that. This is it can like scan for 60 meters. It's kind of pretty large space. And poison estimator is kind of like how much way you drive, and it gives a pretty good position for the car in the GPS and map. Distance sensors is kind of a radar. It's just like the backup radar we have now. Is detect the distance between the matters and the cars. It is safe and perfect. Let's see here the software. It is an image about the software inside of the car. As what I said, it's still testing, so people need to test the car. So they need a version. It's a virtual software to see how the car is creating the imaging for detecting the matters in the map. We can see here the people's it completely like detect the people inside the road, even trees, cars, buildings, anything could detect it. It's almost perfect. There's the second one, cloud computing. I will discuss 3 things, also 3 in cloud computing. One is how cloud computing works, and the practical application of distributed computing and Google Cloud. First of all, about cloud computing, we have 3 concepts here, but I don't want to show it. I want to discuss it to you because it's far more like deep. I don't want to go this deep for just like the class. The cloud computing, like it's just like the picture I show you. The people post their apps or working through the wireless or the internet to the customer HQ. Also, customer HQ is always store the basic apps in their HQ, just like the Google Doc. There is an application like in this. Like we as a customer load this applications, we could work on it, and then they store the information that like we send to the Google Doc, like the document to the data center. Then when we need the processing, like when we need to run an application, they will request the processing cloud provider to process the application for us, and then it goes through the internet to airport, coffee shop, everything like that, or the office in the red hub, the offices, anything like that. This is how cloud computing works during, like they are working through the internet. And this is how cloud computing, like the basic needs for the cloud computing. You need the multi-core processor. It's not required for a powerful, but usually we have a powerful multi-core processors for the server, general purpose graphic processors for software methodologies, virtualization, leveraging the powerful hardware. It's kind of the hardware is virtualization. Is the technology called the virtualization. The virtual is kind of from the like Intel. Wide brands with communication is for here is kind of the network. It means like the fast network or wide branch network. Purification of devices such as the controlling devices, something about the monitor, or something like control the website or the devices itself. Exploration of domain applications, the application just like the Google Doc or Google Cloud Platform, stuff like that. And the practical, application for distributed system is kind of like distributed computing, I think. This is kind of just like the one we said before, but I just wanna use this for a detail about another type about cloud computing. We have used we have discussed about the Google Cloud Computing. This one is different than that one. When we use the computer, we always have to open it for a long time without doing anything. Like in some situation, we have this kind of situation. Like we need to wait the time, or we are watching the movies. But actually, when we work like typing documents, simply typing document, we don't need this much processor. We don't need this much speed. We just need a very little speed for just typing or watching movies. But it is wasting for our electricity or our hardware. So there is an idea about if we're using this performance to help something like scientist research. So it was good for the development of science. So we have many websites such as Wizzo or something like that for distributed computing website, and people could even earning money throughout doing this kind of processing or calculating for their objectives. So this is a good way for us as a student who don't have job for making some money. And this is how that work. It is doing a scientist research about the space. It's calculating the stars, calculating the position of stars, is calculating how that moved. It's the result of these calculations. It actually requires a massive performance for doing massive calculations, massive numbers. That's not like one computer or two computers could do. It costs about uh, 1,000 million years for calculating these numbers. But if we're using like many computers to doing this together, it will be faster than ever. This is the like basic point of doing the distributed computing. And finally, I want to talk about the Google Cloud. Google Cloud, as we say, as a teacher say in class, we have talking pretty much enough about Google Doc, like Google Doc, Google applications, or even Google Classes that we use now. And this is how this is how Google Doc work, like Google Cloud works. Like we have devices in the left, and then we doing this from the cloud. It like through these gaming services. Not actually some applications are gaming applications, or we're doing this kind of the process to use these cloud speeds. And then Google Doc, as we said, Google Doc is the most useful tool for us because it's free, and this is using, like, it allows to use the Microsoft style document. Finally, is Google Cloud Platform. So everything, even the Google Doc and Google, like anything applications about Google browser is set up with the Google Cloud Platform. So this is a basic platform to set up those apps, and also you can actually create the apps throughout the Google Cloud Platform, and this is a perfect platform than before, than the Amazon AS or even the Asuka for Windows. Thank you for watching. This is all I need to present.